Hello students, I am Shlok Kulkarni. I welcome you all back to my YouTube channel. Thank you for showing so much interest and continuing with the lectures consistently. Today we are going to start with a new quiz of random questions picked from topics of Net, REGS, NAV, Tech, and this will boost your preparation, your confidence, your exam preparation. So let's start with question number 1 for today. The aerodrome elevation is the height of what? The aerodrome elevation is the height of what? So particular aerodrome, any aerodrome you take, okay, in the airport directory book or supplement, you will find information about that airport, the runway information, the runway length, the lights available, the frequencies, the telephone numbers, everything about that airport. And also along with that, there is elevation mentioned, okay, of that airport. Now you take any airport, that airport will have uh, okay varied topography, up down, there is upslope, downslope at different areas. From a far point of view, from a far perspective, it looks straight and level, but there are minor variations in height of the ground level of any place. Okay, so now when we print or when we put values of aerodrome elevation in airport directories or approach plates or any other standard instrument departures in which they have to mention airport elevation, okay, or aerodrome elevation. So what point or what elevation do they mention? So according to ICAO definition, aerodrome elevation is regarded as the highest point on the landing runway. Okay, is regarded as the highest point on the landing runway. So the airport might be very large, okay, in area, but we have to take the runway at that airport, the runway in use or the landing runway, okay, all the runways, and out of all the runways, the runway with the highest point will be the elevation or aerodrome elevation or elevation of that airport. So the highest point on the landing runway is called aerodrome elevation. So over here you can see in the ICAO glossary I have picked this picture. Aerodrome elevation definition is straightforward given. The elevation of the highest point of the landing area. Okay, so remember it's landing area, not takeoff area. Okay, so remember the words. When it comes to definition, your words should be accurate and proper. Question number 2. On Earth, points of zero variation are called what? So what is variation? Variation is the difference between true direction and magnetic direction. Okay, what separates true and magnetic is variation, right? Now we have on Earth places, points joining, lines joining places of equal variation. Okay, variation more than zero, equal variation. We call it isogonal lines. Isogonal lines. This one of equal variation. Now, if there are lines joining places of zero variation, means places having no variation at all, and so many points. So, line joining those many points of zero variation is called an agonic line, or those lines are called agonic lines. So, points of equal variation isogonals, points of zero variation will be agonic lines. Straightforward theory questions. So make sure that however theory questions are asked, theoretical questions in which you don't have to solve anything, no numericals, no maths, no formulae. You must score full marks in those theoretical questions. That also saves your time because when you solve numerical questions, lot of time is spent in them. Question number 3, again regulations. What is the name of the taxiway connected to a runway at an acute angle, designed to allow aeroplanes to exit the runway at fast speeds than is possible on any other runway taxiway intersection, thereby reducing runway occupancy time? Now let's look at two types of pictures, two different pictures I have pasted here. Now let's look at picture number 1. Over here you can see that we have a runway, okay, that we have a runway, and this runway is connected to a taxiway, is connected to a taxiway. Okay, you can see this, everything in yellow is in taxi, everything in white will be your runway. Everything in white will be your runway. Okay. So here you can see in this diagram, same diagram I have drawn here. Your runway is connected to the taxiway, right? But the thing is, the angle between this runway and taxiway that is formed is how much? 90 degree. Or both that means your runway and taxiway are perpendicular to each other, right? Now in such a case, when you have to taxi your aircraft from taxiway, let's suppose you have got your takeoff clearance and you are instructed to align with the or to line and hold up on the runway, line and hold on the runway which is in front of you. So you add power, you enter the runway and you line up with the center line of the runway, and then you are waiting for taxi takeoff clearance. Okay. Now the time that is spent, okay, to maneuver your aircraft on the runway and to turn that aircraft 90 degree and then align with the center line of the runway is is large. Okay. Okay, it's too much. So the time spent, okay, in case of such examples where runway and taxiway are connected at 90 degree, the time that you spend in turning 90 degree and then aligning with the runway is too much. Okay, so that results in much more runway occupancy time. That means you are occupying the runway at lengthy times for a large length of time or duration of time. Okay, so due to that, the rate at which aeroplanes are taking off from that airport and landing at that airport will be affected. Okay, so in order to facilitate air traffic, okay, in order to facilitate takeoff and landings, we have made a development in the construction of the runway and taxiway. Okay, so before we go that, a quick recap. We have this at 90 degree, and when we try to turn our aeroplane at 90 degree and then align with this runway, you will require a large radius of turn, okay, which will result large radius of turn, therefore very slow speed differential braking and then align with the runway. Now this is a small aircraft in front of you, but in case of big heavy aeroplanes, the time spent on the runway to make a 90-degree turn is still more. Okay. Now for takeoff, in case of lining up in case of lining up with the runway, for the example of takeoff, the time is still less. But when you take the example of landing, when aircraft lands on the runway, okay, when aircraft lands on the runway, let's take this example. When aircraft has to land on the runway, let's say aircraft has landed from here. Okay, aircraft has landed from this side. Okay, when it lands on the runway, it has to come to a complete stop or at a very slow speed. It has to decelerate its speed to minimum before it can come towards this taxiway and then make a 90-degree turn and then exit from the runway. In case of takeoff, okay, aeroplane is parked here, so it will begin from a slow speed, then accordingly it will add power, decrease power, and then turn and align with the runway center line. But in case of landing, when you are coming at very fast speed from the air and you touch down on the runway, the speed of aircraft is very fast. Okay, and at that speed you just cannot land on the runway and then turn on the taxiway. Okay, you will have to first bring your aeroplane to a minimum speed, okay, minimum speed at which you can taxi on the ground, and then slowly steadily you will turn your aircraft 90 degree and then come on the taxiway. Again that takes a few seconds, 10 15 seconds. But when you add those 10 15 seconds for every aircraft that lands on that airport, okay, on that runway at that airport, for those 24 hours day duration, that will add up to too many hours. So in order to save that much time and accommodate much more traffic at that airport, we will have to construct a runway and taxiway in such a manner that will bring down this runway occupancy time of each and every aircraft. So we have something called this. Now look at this diagram. Here we have the same runway, okay, but this runway is connected to the taxiway not at 90-degree angle but at a slant angle or acute angle depending from which direction you are landing and taking off. Okay, so it is aligned at a slant angle or acute angle, so like this and like this instead of 90 degree. So let's say you are landing from this side of the runway. Okay, you are landing from this side of the runway. You will land on the runway. Okay, and instead of bringing your aeroplane to a full stop or very minimum speed, you can keep that momentum. Instead of that, you can keep the momentum of aeroplane and you can just turn at a slight left angle and then exit from the runway on this particular taxiway. That will be much more easier, okay, to turn your aircraft with the momentum that it already has and then enter the next taxiway. Okay, so this is a little bit of development. Okay, very clever development that they have made to reduce runway occupancy time. Okay, so this 90-degree taxiway runway intersection has this disadvantage that it increases runway occupancy time because of the radius of turn that is required to make to enter the taxiway. Especially this problem is aggravated for landing because you come at very fast speed, you have to bring your aircraft to a stop under control and then turn, right? But in this case, since these are at an angle, it becomes easier to turn a little bit to turn, in this case left at a little bit angle, and then with that momentum enter the taxiway, and then as you enter the taxiway, you can come to a stop, slow down your speed gradually. Next point is, this is one real example where we have the long runway over here. We have taxiway here, one taxiway this side, another here. So both these taxiways are also again at acute angles. But one taxiway over here, I don't know if you can see it or not, that is at 90 degree, which is connected to the threshold of the runway. So many airports nowadays, okay, so keep an eye next time whenever you go or fly, that the taxiways, what is the angle between the runway and the taxiway. Now coming back to the question, such taxiways are called rapid exit taxiway. Such taxiways are called rapid exit taxiways. And now in regulations, you will find aerodrome chapter. This rapid exit taxiway center line will have particular sequence of lights. So it's your homework to find that out. What are the color of those lights? Okay. So there are, I will give you one hint, there are alternate colors. Okay. So you have to find those colors in that chapter. Question 4, what is right about density? Now density is a thing which is influenced by three factors very heavily. Okay, first of them is humidity, next is pressure, and third is temperature. Okay, so humidity, temperature, and pressure will affect your density. Now, next point. So, let's check how an increase in temperature or increase in humidity will affect your density. So, I'm going to make this table and you have to remember this table for your exam, for your navigation performance, meteorology, regulations. Okay, very important. So we have density here. Just a second. Now let's say first. So out of three factors, let's consider every factor one by one. When temperature increases, temperature in atmosphere increases, what will happen to the density of air? Now, when temperature increases, we saw the example of convection in previous two quizzes, is that when density increases, we will have what? The volume expanding or volume increasing, and as a result of that, density will decrease. For example, during convection, when you heat a pot of water, the water layer which is close to the ignition, it will first get heated up, okay, compared to the water layer which is at the top. The water layer which is close to the ignition, when it gets heated up, its volume increases. As a result, its density will decrease. Density and volume are inverse in proportion. Okay, so when volume of an object increases, the density, what is density? The concentration of particles, or how closely packed, okay, an object is or a substance is. Now, when the space increases or volume increases, there is extra space for that object to live in or to exist in. As a result, the density decreases, or let's say there is an area, particular area or city. Now, when that city grows, okay, there is more and more land area that is added to a particular city, the population in that city get more area or a new area to migrate to settle. So as a result, the density of the traffic at one particular area decreases or reduces, okay, and that traffic is evenly distributed to new areas and old areas. So density is how closely packed a substance is. Another example over here, this is your object. Now, in this case, if density is very close to, if these particles are very close together, we say density is high. If these particles are away from each other, so that means this object is very less dense. The traffic inside it is very less. So density less. So same thing. Now, when temperature in the atmosphere increases, the air mass will, its volume will expand. It will grow in size. As a result of that, the density of that substance will decrease. So it's remember, when temperature increases, density decreases. Point number two, humidity. When humidity in atmosphere increases, what happens to density? So now a humid air is less dense than dry air. Okay, according to ISA, one condition of ISA is that air should be dry. But in real life, we don't have dry air, we have humid air. So humidity, when humidity in the atmosphere increases, your density will, in that proportion, it will decrease. When pressure increases, atmospheric pressure increases, what happens? Your density. Now, when atmospheric pressure increases, your density increases. So at mean sea level, we have maximum atmospheric pressure. Okay, not maximum, but according to ISA, we start from mean sea level. As you go below the mean sea level, again the atmospheric pressure will go on increasing. So let's say at mean sea level, you have very high pressure. As you go above from the mean sea level to higher atmospheric layer, atmospheric pressure will keep on decreasing, 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 right? So when atmospheric pressure decreases, your density will also, density of air, as you go higher up in the atmosphere, what happens? The density of air, that air becomes thinner, thinner and thinner. When you are close to the mean sea level, the air that you breathe is thick. But when you go to high mountains, you are unable to breathe because the density of air, the atmospheric pressure there is very low. Okay. So atmospheric pressure has a very large influence on air density. As atmospheric pressure decreases when we go higher up in the atmosphere, density also goes on decreasing. Okay. Volume goes on expanding. As any object you take, when it goes higher and higher up in the atmosphere, what happens to its volume? It increases. Okay, you can check in the YouTube. Okay, when there are many YouTube videos in which passengers in aircraft have taken a packet of lace or kurkure, and when on the ground that packet is compressed due to atmospheric pressure acting on it, but the same passenger, when he takes that packet of air at 30,000 feet, 25,000 feet, that packet of lace will expand in size. Okay, it will grow in size. You can see those videos. So those are demonstration that as you go higher up in the atmosphere, atmospheric pressure decreases. So you have to remember, when atmospheric pressure increases, density increases. Let's say you're taking off from a mean sea level, and on that day, it's your good luck, good fortune. Atmospheric pressure has increased, high pressure is intensifying. So you will get a very good density of air. Your aircraft engine will produce extra power. Okay, you will need lesser takeoff distance, less landing distance. So this density of air definitely has effect on your aircraft performance. Okay, now next thing is, I will erase this part. So this relationship you have to remember. Okay, this is very important in calculating density altitude. Same thing I am writing here. So when now let's say your temperature has decreased. Now when temperature decreases, that means when temperature gets cold, what happens to your density? Density increases. Density increases. Opposite of heating. Okay, so as your temperature gets cold and cold, your density will decrease. But what happens when you cool down a particular object or air mass, it will get compressed and compressed. As a result of it, the air particles will come close and close together, and it will be closely packed depending how to what temperature you cool it down at. Okay, so as temperature decreases, the density will increase. As humidity decreases, your density will increase. Okay, and then as pressure decreases, your atmospheric density will decrease. So remember these two comparisons that I have made over here. In temperature increase, temperature decrease, humidity increase, humidity decrease, pressure increase and pressure decrease. So you have to remember. Now one note that I want to tell you is that previously I told you that as atmospheric pressure decreases, as we go higher up in altitudes, your density also decreases, right? Pressure has more dominating factor on density. Now you will see over here I have written temperature decreases, density increases. So as we go up in the altitudes, higher layer of atmosphere, temperature goes on decreasing. It becomes colder and colder as we go higher up in the atmosphere, right? So according to that logic, your density must increase. But over here, so finally, what do we have? That we have that on one hand we have pressure decreasing, so density should decrease. On the other hand, we have temperature increasing, temperature decreasing, getting colder, and therefore density should increase. So which of these two elements has more dominating factor? So out of temperature and pressure, pressure will have more dominating factor on density, and so density decreases instead of increasing because of cold temperature. So remember this for your Viva exams, interviews, okay, or if your instructor asks this anytime. So remember this important statement. Next, what is right about density? The question, density decreases when humidity increases. So over here, humidity increase, density decrease. So correct option is option A. Relative density at 20,000 feet is 20%. So let's check. So at 20,000 feet, approximately 18,000 at on this in this row, 18,000 feet height, your relative density is 56.4 at 18,000 feet. So at 20,000, it will be somewhat less than 56%. Let's say 50%, 51, 52%. So it is definitely not 20%, right? Relative density is definitely not 20% in comparison to mean sea level density. So B is eliminated. A rise in pressure will fall density. That is wrong. It will increase density. Fall in temperature will decrease density. So as temperature falls or it becomes cold, your density increases. So delta is also wrong. So therefore option A is the correct option. Question 5. Which of the following will GPWS not give warning about? So ground proximity warning system. GPWS is ground proximity warning system. So it is a radio navigation equipment, okay, which gives alerts and warnings to pilots about the high ground below the aircraft. So if there is any high obstacle or any high obstruction below aircraft, and so you will get appropriate alerts, and when that alerts are ignored or not corrected, they will transform into warnings. Okay, so this is a radio navigation equipment which is created to prevent CFIT, which is controlled flight into terrain accident. Basically, when due to pilot error or human error, aeroplanes are crashed on the ground or in the mountains like that. Okay, so to control that or to bring those accidents down, CFIT, controlled flight into terrain, we have GPWS system. And to avoid crashes in the air, we have TCAS, traffic collision avoidance system, which gives you alerts in the sense traffic advisories and resolution advisories to avoid other traffic around you, which if it gets very close to you can create a safety hazard. Okay, so let's about GPWS now. Now ground proximity warning system tells you or keeps you away from the ground below you. Okay, so basically aeroplane should stay at a safe altitude from the ground below. Okay, unless it wants to come down for landing, right? So in no circumstance it should come down at a very fast rate of descent, excessive rate of descent, or it should come down for landing without landing gear or without using flaps, right? So in some unique situations, this radio navigation equipment, which is GPWS, it comes to know that something is not right. The aeroplane is expected to do something, but it is doing something else. So there are some 6 to 7 different or unique situations in which aircraft, if it continues to descend, it can create a hazard or safety hazard, and in such and such cases, ground proximity warning system is designed to give alerts and warnings. So first mode or first situation when you get an alert is that when there are when there is a rate of excessive descent. Okay, rate of descent is excessive. Okay, so in that case, you will get a warning of sink rate, sink rate. So alert is sink rate. And if you still don't arrest that rate of descent, or you don't decrease your rate of descent and you continue at very fast rate of descent towards the ground, the warning will be pull up, whoop, whoop, pull up. Pull up means pitch up. Okay, is you have pitch up or increase the altitude of aircraft or bring the nose of aircraft to horizon or above the horizon, meaning stop your descent. So this is the simplest of the modes. Mode 1, excessive rate of descent. Alert is sink rate, telling you that you are sinking or descending at a very fast rate, and warning is to pull up. Second mode or second situation when you can get a alert and warning is when when your terrain closure rate, that means you are getting close to a particular terrain, okay, at a very fast speed, excessive terrain closure rate. Okay, so if there is a mountain ahead of you or just below you or at a very short distance in front of you, and if you are going close to that, okay, at that level and very fast, okay, maybe there are bad visibility conditions or you have not resetted your altimeter setting, okay, on a very cold day or a low pressure region. So in that case, you may be flying very close to the terrain ahead of you. So in that case, it will generate an alert of terrain, telling you that it's terrain in front of you or just below you, and there is a danger. So the immediate action should be to pull up. The same warning as for mode 1, whoop whoop, pull up. Okay, pitch up. Third is mode 3, descent after takeoff. Now as soon as you take off or lift off from the runway, you are expected to maintain a certain rate of climb. Okay, that rate of climb should be maintained. It should not decrease or you should not descend just after takeoff, because when you just take off, you are at a very low height from the ground surface. There might be huge towers, buildings, antennae, mountains, even mountains, just at the end of takeoff, just at the end of your takeoff runway, okay, or at the end of your airport. So in no case you should descend or decrease your rate of climb, because there can be a possibility of some mishap or accident. So in this case, you will get a warning of directly don't sink, don't sink. Okay. So this warning can be created after takeoff or even after you initiate a missed approach procedure. Okay, even after missed approach procedure, you are expected to maintain a proper rate of climb, because during landing you come closer and closer to the ground. And if you decide to abort that landing, to cancel that landing and just add power and then go up in the air, you are expected to maintain a particular rate of climb. Okay, because you are very close to the ground basically. So both during takeoff and landing phases, if you, in case of landing, if you initiate a missed approach, you will be given this warning. Okay, so you have to, that is descent after takeoff, okay, or descent after establishing a particular rate of climb. Okay, only in two phases, takeoff and landing phases, when the system knows that aircraft landing gear is down, okay, aircraft flaps are down, okay, in those cases. Question number, mode number 4, correction. Unsafe terrain clearance. That means the clearance or the separation between the mountain and your aircraft is unsafe, or any ground or any obstacle below you and you is unsafe or is not sufficient. Now mode 4 has two types, mode 4A and mode 4B. Okay, mode 4A and mode 4B. So 4A is that when you are coming in for landing, but your landing gear is not down. That means you are coming in for landing with your landing gear up. That means landing gear is not in its down position. So without landing gear, can you land that aircraft right, right or wrong? That is wrong. You cannot land that aircraft on the runway. You need landing gear. You need aircraft wheels. So you will be given a warning of too low terrain or too low gear. Okay. If you are coming down for landing without flaps, okay, so you are expected when you are coming for approach landing, you should have 30-degree, 40-degree flaps normally, okay, high angle of flaps. So if you don't have sufficient flap configuration set for landing, again you will get a warning of alert, too low terrain, warning, too low flaps, okay, constantly. That is, flaps is mode 4 Bravo, landing gear is mode 4 Alpha. Mode 5 is descent below glide slope. Now, when you are coming in for approach and landing with the help of ILS, okay, or you are coming in for ILS approach, and you are expected to maintain the runway center line with the help of localizer needle. You are expected to maintain the glide slope with the help of glide slope needle. Now, standard glide slope is 3 degree. Now, it is a rule that if you descend below glide slope, okay, below a certain limit, going down below a glide slope is acceptable, but there is a limit set. If you cross that limit, okay, you cross that threshold and you go below that, you have to instantly initiate a missed approach or go around, because in that case your flight won't be considered in a stable, or your flight won't be considered to be in stabilized approach. Okay, so such a case in which you descend below a particular threshold of glide slope, you will be given a warning of glide slope, glide slope. Because what happens when you descend below glide slope when you come in for landing? As you go below down a glide slope, you are actually going close to the ground surface below you. There can be an obstacle, a building, a tower, anything can be there. So that is not a safe situation. So you either be on glide slope or you be away above it, that is acceptable. But also if you are above a particular glide slope, there is a limit set for that too. If you are too much above, again you have to initiate a missed approach or go around, because your approach won't be considered stabilized approach. Next is mode 6, Okay, in some advanced versions of the GPWS, you have situational awareness, meaning if your bank angle is too much, okay, you will be given that warning. And when you come in for approach, ILS approach, okay, or any kind of non-precision approach, and you are going to, and you have achieved your decision altitude or decision height or minimum descent altitude or minimum descent height, there will be a call minimums, right? Okay, so that means at that height or altitude, you are expected to make a decision to continue to land on that runway or to go around. So that is also output that is given by GPWS depending on the system that is installed in your aircraft. Mode 7 is wind shear information. Okay, especially when you come in for landing and you are very close to the runway, there have been instances where aircraft is coming in for land and suddenly there is a wind shear and aircraft has made a very hard landing because of that due to sudden reversal of wind direction, speed change, all your calculations or all dynamics change. And as a result, during last moment, okay, at last moment something bad happens, hard landing happens or aircraft suddenly initiates a go around or missed approach. So in that case also if system detects wind shear, it gives you wind shear warning. So just go around, make a second attempt or go to another airport. So these are the different modes of GPWS. Basically, the goal is to keep you away from the terrain below you when you should not be, when you are not expected to be at that place. Okay. So which of the following circumstances it doesn't give warning? So you do get a warning of high rate of descent. You do get a warning of approach with landing gear, uh, landing gear not locked down, not okay. That is missing. This is typing error, so not locked down. You get that warning also. You also get a warning of when you are approaching with flaps up. Okay, the warning that you don't get is option number Charlie, which is the correct option. Rising ground ahead. In case in front of you, in much front of you, there is going to be a higher and higher ground. That means the topography is going to increase in height in front of you, and the system wants to give you a alert, okay, or it wants to give you a reminder, or it wants to prepare you for what's coming next. Okay, so this GPWS ground proximity system doesn't give you any indication of that. Okay, the system that gives you an indication or message of any rising ground ahead is enhanced ground proximity warning system. Enhanced. So that is a technological development or an advanced version of GPWS, okay, in which you also get a display on your screen of any rising terrain, the terrain increasing in height in front of you. Let's go to question number 6. Dynamic pressure increases with what? Now there are two kinds of pressure, static and dynamic. Okay, static and dynamic. So static pressure is the atmospheric pressure that is constantly acting on me. Whether I am moving, I am sitting, I am not doing anything. The pressure that is always felt on the body is atmospheric pressure or static pressure. Dynamic pressure is when you move. Okay, whatever speed you move, the pressure, there will be additional pressure, addition to static pressure acting on your body, and that will be called dynamic pressure. Okay, due to dynamic, due to momentum. Okay, so over here, when the wind is coming from behind, okay, it takes the umbrella along with itself. There is a pressure or force acting on the umbrella, and due to which the umbrella turns upside down. Okay, so that this is the effect or consequence of dynamic pressure, the pressure that is created. So dynamic pressure or kinetic means something which is moving, is the pressure we feel from moving air, moving wind, propeller wash. Okay, so dynamic pressure is what is how we get airspeed indication. Moving car, okay, when you put your hands out of a moving car and just keep it there, you will feel pressure acting on your hand at a very tremendous force depending on the speed of car, obviously. Okay, so that is dynamic pressure. Formula is half density V square. Half density V square. That means your dynamic pressure increases with increase in density and it increases with velocity, but square of velocity. Okay, so don't confuse between B and C, Bravo and Charlie. Bravo is density, velocity and density, but Charlie is more appropriate, square of velocity. So select the most appropriate option. Question 7. Your vertical speed indicator is 100 knot, glide slope is 3 degree. What is the rate of descent? So rate of descent formula is feet per minute, speed into glide slope divided by 60. Now speed is 100 knots. Convert that knots into corresponding feet per minute. So 100 into 101.3 into 3 divided by 60. 1 knot is equal to, for those who don't know, 1 knot is equal to 101.3 feet per minute. Okay, so that's why 101.3 I have put over here. Next is rate of descent. Use your calculator. Rate of descent will be equal to approximately 500 feet per minute. 5 into 101.3, approximately 500 feet per minute. So option C is the correct option. Okay, just in exam, don't forget to convert the units, knots to be converted into feet per minute. Otherwise, your answer will be completely wrong. Last, what is the purpose of the outflow valve? So this is your technical cabin pressurization. Very important for your CPL exam as well as for your type rating. When you go for type rating of any aircraft, cabin pressurization will form a very important part of your training, your ground study as well as your simulator training. So you should know the basics, and that basics you will learn in the Oxford. So the purpose of the outflow valve is to maintain the desired cabin pressure. Now just some basics. Why do we need cabin pressurization? Because a human body needs oxygen under pressure. Okay, we receive sufficient amount of atmospheric pressure on me at mean sea level, and therefore we get proper supply of oxygen to lungs, to heart, to brain, all vital organs of our body. As we go up in the altitude, the air density decreases, the air becomes thinner and thinner, atmospheric pressure also decreases, and therefore our human body functions, bodily functions get affected. Okay, as we go up in the altitude because of insufficient atmospheric pressure. Okay, the oxygen content in the air remains the same, but since the pressure goes on decreasing, the oxygen that reaching to all our organs is under less and less atmospheric pressure, is under less pressure. Okay, and therefore insufficient flow of oxygen goes to the organs of our body, and therefore our body functions are hampered. Our body cannot function properly. Okay, and it is not healthy for us, also it is not safe for us in extreme situations. We always need oxygen to live, and if we don't get oxygen, that oxygen under sufficient pressure, okay, it will cause death to us. It can be fatal or it can be very serious. So that's why we need cabin pressurization, because irrespective of outside atmospheric pressures, our aeroplanes are designed to fly at very, very high altitudes. But they will not fly at high altitudes all by themselves. They transport passengers from one place to another place. And for the comfort and safety of passengers, it is very important that there is a provision for atmospheric pressure in the fuselage of aircraft or any part of aircraft where human organism is going to be situated or is going to sit, right? And that cabin pressurization will be created by aircraft engines. So cabin pressure air or highly compressed air enters the fuselage of aircraft in the cabin where all passengers sit, and that cabin air needs to go outside that fuselage also. So the air that enters is also exhausted, is also dumped outside, and that is done with the help of outflow valves that we have in this picture. These outflow valves, what they do, the cabin pressure air or the cabin air that is existing in the cabin, it sends that cabin air outside in the atmosphere at a particular rate, okay, depending on how much pressure do we have to maintain inside the cabin. If we want to maintain a high cabin pressure, the outflow rate, that is the rate at which cabin air is sent outside, okay, or is dumped outside in the atmosphere, will be very slow. If we want very low cabin pressure in the cabin, all the cabin air or much majority of cabin air will be sent outside in the atmosphere. So these outflow valves regulate this flow of cabin air inside and outside. Okay, and as a result, it indirectly maintains the cabin pressure or controls the cabin pressure inside the cabin. So this is the basic thing about your outflow valve. So outflow valves maintain the desired cabin pressure, the cabin pressure that we want. If we want more cabin pressure, outflow valves will prevent cabin pressure from going outside or cabin air from going outside. If we want less cabin pressure inside, so majority of cabin air will be sent outside. With this question number 8, we have come to the end of this lecture. I hope you have understood it, you have liked it, you have learned something new today, as I always say. So let me know your comments, your questions, your feedback with the like button, the comment section. You can post your questions, your doubts. Subscribe to this channel without fail and do share this video with everyone. Thank you for your time. All the best.